and welcome! In this video we are going to explore GPlates, a powerful tool for visualizing and analyzing plate tectonics and geological data over millions of years. This tutorial will help you to get started. To begin, head over the official GPlates website. You'll find downloads available for Windows, macOS and Linux, so make sure your system meets the requirements. In general, any modern computer should be fine, so choose the version that matches your operating system and install it like any other software. So you click here, you scroll a little bit until here, download selection, and here you can find this one for Windows, but you have the other ones, and you select this one too. Here you can enter your name and your email, and now you get this message and you can download the datasets and the software. So after a while you will see that you have this new link, so you can open it and you see this GPlates setup, so you can double click on it. You hit on yes and you have the setup of the software. So basically here it's in French, but you will have it in your native languages, so you can accept the license, can create GPlates desktop icon if you want, and here you can browse the path of the installation for your software. So I will choose another one. I will choose this path for me. So let's go for the setting up. At the end of the setting up you will see this message, so you can close this window. And now you can find the GPlates API. You can open it, so you will see this new window. So now let's explore the interface of this geological software. So when you launch GPlates, you will see a 3D globe viewer. Here you have the time controls. You find here a basic series of menus and toolbars, and a layer panel where your geological data will be. You can select the different view of your map. So you can choose Robinson, for example, or maybe 3D orthographic. So there are a few key concepts you should know. Plate reconstructions. So this is a process of moving geological features through time based on tectonic motion. The rotation file. This file contains the plate motion data. So basically it tells GPlates how each plate moves or has moved over time. Features collections. These are datasets containing plate boundaries, mid-ocean ridges, volcanoes and more. Plate IDs. Every tectonic plate has a unique ID, which links it to its motion and associated features. So understanding these elements is crucial for working effectively in GPlates. So let's explore geological data. Just to have an overview of all the files that are available since you have set up GPlates. So you can find the folder of the software on your computer, and so you can have a look of all the files that are available, but for this tutorial we'll just have a little overview of the datasets. So you can find here in this folder all the files that are available. So maybe you have to extract the files and you see many datasets that could be launched in your GPlates project. So one of the most widely used data sources is the EarthBite project, which provides open access plate tectonic models and geological features. So you can also find additional datasets online. So it's here in data and models, and you can find here the GPlates and datasets and resources. So just take time to explore all the datasets and models that are available, and write any question you have in the comments if you need. So to use GPlates, we need a model of plate motion. Some of the most common open source models are the Paleomap project, the model designed by Müller et al. In 2016, or the one by Meredith et al. In 2021. You can also use, like we just saw, EarthBite plate models, but the one I wanted to show you is this one. Maybe, I don't know if it's... okay, Müller et al. Is this one. So you can drag and drop this file into the GPlates software. Okay, great. So now you see that the geological layers panels just opened, and you have your beautiful deforming model that just have been launched. So let's look at a little example to begin. So by loading a global plate model, we can reconstruct the breakup of, for example, Pangea, the ancient supercontinent. So use the time slider at the top to move backward in time. It will animate Earth's surface through time from 200 million years ago to today. So you can play this model and then move forward to see how continents drift to their current position. So as you scroll through time, you see the continents drift apart. Here you have the geological layers that you can control. So for example, if you don't want to see the velocity, you can click on it. And you see forming the Atlantic Ocean, for example, or here, the Indian subcontinent moving north and more. So it's a powerful way to visualize geological history and understand the plate tectonic in actions. So for example, here you see that you can select another view if you want to have a look at it on Robinson view, for example, or maybe, I don't know, in Mercator. At any moment you can have a screen on it, and now we will see how to set the symbology of your geological features. So here you see that you can move the items. The item hierarchy is really important because the first layers will be displayed in first. So for example, if you want to change the symbology of the cratons, here you can set draw style, and you can settle it by default, or maybe you want a single color, a feature age. Here are many symbological layers. So for example, I don't know, I will settle it in white. So for example here, a really important thing, so it's the continents of Meredith et al. Symbology. So here you can, of course, choose to fill polygons or not. Here you see that you have many polygons that are gray, but if you want to fill, to apply another colors, you can choose it too. So you can play with all these layers to make a great geological GPlate models. Now we'll see another tectonic model. that you can find here, GPlate Quick Start Deforming Model. So you can open this. So you have to read this first. You can contact the authors of this model. And here you drag and drop this model. Yes, you can discard. Here it is. So here you can open a project, save a project, you can open feature collection. Basically, I'm looking for the geological panel. It's here in the menu window, show layers here. If it disappears, you can display it here. So like the previous model, you can play with the different layers you have. And for example, we will, yes, right here, you see the Continental isochron. Here you have the plate boundaries. And of course, here you have the topography model. So that's it for this introduction to GPlates. Let's think about this. What can plate reconstructions tell us about future geological changes? How oceans have opened and closed, so how mountain ranges, earthquakes and volcanoes are tied to plate boundaries. So there are many final reflections you can have. So keep exploring, keep questioning. If you find this helpful, don't forget to like, subscribe and leave a comment if you have any questions. I found this GPlates model really interesting. So let GPlates be your time machine.